Something like this. This is kind of similar to some of the problems on your quiz that we've been struggling with. If I want to find dimension A, it is a vertical dimension. So that means I'm going to use my other vertical dimensions to find it. But this is more complex than some of the other examples we looked at, where you could just add some together to make a total or subtract. So what I'm going to do here is I'm going to use a little bit more complex strategy. That's a vertical dimension. So what I'm going to do is I'm going to measure using all my other vertical dimensions. I'm going to locate every element, the end of each of these vertical dimensions, as a distance from a starting point or a baseline. Now my baseline is going to have to go horizontally. I call that my 0 point, right? I need to locate the position of both ends of that piece that I'm trying to find, piece A. So to find this end, I'm going to start one side of my figure. So this is 0. I go up 46 here, so this is at 46. Now my horizontal pieces here cannot change my location, only the vertical ones, because I'm looking for a vertical dimension. So if this is 46, this is also at 46. That distance from my baseline down here. I forgot to label that, didn't I? That would make this a lot easier if I did that. So I've got the measurement in there, makes this easier. So now from 46, I'm coming back 12 units, so this is going to be at 34 here. So that location right there is 34, which makes this location 34. What that's saying is, from here down to my baseline is 34 units. Make sense? Kind of like using a coordinate system if you're thinking about your CNC grid. Now, I have to locate the bottom. So starting here, this goes up 16, so I'm at 16 here. That makes this 16 here. Coming back 6, so where am I at here? 10. This then also has to be at 10. Going up 38, so this is 48, so this is 48. Coming back 20, that's 28 and 28. So A has to be 6. That's the difference between the 28 and the 34. Finding B, I'm going to do a similar thing. Now, I can pick either end. It really doesn't matter which end. Usually I pick the end furthest away from it because then it's easier. But I'm just going to go ahead and pick this one. I'm going to use that as my baseline. Let me actually try that so it actually stays on the end. There, that's my baseline right there. So now I'm going to go up 18 here. Now I'm going to the side, not up and down anymore. So I'm going over 18. This is at 18. So this is at 18. That's one end of my dimension B already. Now I need to find the location of this end. So I'm going to have to come around this way. This is 8, so here's 8. That's 8. What's this? Plus 20, so this will be 28. 28. How about this right here? What's that going to be? 64, right? 28 plus 36 makes 64. So here we're at 64. How about here? What's this going to be? 64 minus 16. Back to 48. So this will be 48. This will be minus 14, right? So 34. Makes this 34. So the ends of that are 34 and 18. The difference would be 16. And so this is a pretty complex part to be finding missing dimensions. That's one thing you can do is think of it as XY coordinates. We set a 0 for our vertical dimension and just find this location from the 0 line. Set a 0 here for a horizontal dimension and find its location from the 0 line. If you can locate both ends, if you can locate both ends, its length has to be the difference in the position of the ends. Okay, well, to finish off today, to finish off the week, okay, so now I want to talk some more about fractions. We talked a little bit back on Tuesday about fractions being a single number with two parts. Like here, 3/4 is a single number with two parts. The 3 means we have 3 of something. That's our count. The 4 is what we have. We have 3 of the fourths. Kind of like having 3 inches or 3 pounds. We have 3/4. So our first step is to define what it means to be a fourth. So the easiest, simplest way to do that is probably go back to our elementary school illustration. Pretend that's a circle. Think about a pizza or a pie or whatever. I'm going to go with pizza. And the fourth means that pizza is cut into 4 equal pieces. Pretend those are equal. So the fourth means that every whole object gets cut into 4 equal pieces. Or another way of looking at it is that it takes 4 of those pieces to make one whole object. So now we have 3 of them, so we color in 3 of them. So we have 3 of the fourths. So 3/4 literally means it takes 4 pieces to make a whole object, and we have 3 of them. Well, so we looked at an example, I think it was like 1/3 plus 2/5 or something like that. And we said we can't add them the way that was. We mentioned we might be able to change their names. So one of the first things we want to be able to do with fractions is to change their name. The simplest way to rename or change the name of a fraction using this illustration would be to just cut the slices. I'm going to cut each slice into 3 equal slices. Pretend these are equal. Now, how many slices or how many pieces does it take to make one whole object? Kind of what comes out to 12, right? I had 4 before. Each of them got cut into 3, so 4 times 3 makes 12. How many pieces do I have? 9. I had 3 before. Each got cut into 3, so 3 times 3 makes 9. So what I have there right now is 9/12. Do I have any more or less pizza than I did before? No. So 3/4 and 9/12 both represent the exact same amount. They just look different. The reason we were able to change their appearance without the value is based on what we did right here. We multiplied by 3 over 3. 3 on top and 3 on bottom. If you think of that as a fraction, this means it takes 3 pieces to make a whole object, and we have 3 of them. Okay? In other words, it's one whole object. We multiplied by 1. And what happens to a number if we multiply it by 1? Nothing. It stays the same. We can see here we can change its appearance, but we cannot change its value. About halfway through the semester, when we were talking about measurement conversions, this is very important. This idea here of multiplying by 1 is how we convert measurements. It's what we call a unity fraction. We're going to use several different forms of them throughout the semester. So anyway, the consequence is we can multiply the top and bottom of a fraction by the same thing. Here we just picked a random number, the 3, and multiplied by it to rename it. Most of the time, though, we have a specific name that we want to achieve. So if we have 3/4, and let's say the name we want to have is 20th. So we have to use that name to figure out what we're multiplying by. So we're going to ask, what did we have to multiply 4 by to turn it into 20? 5. If you didn't see that, you could just reverse it and say, okay, 20 divided by 4 equals 5. So 5 is what we had to multiply by. So then what do we have to multiply the 3 by? 5. We have to multiply the top and bottom by the same thing. 3 times 5 is 15. So 15 over 20 is the exact same value as 3 over 4. What if I have 2/5 and I want to change this into 30/5? What do I have to multiply the 5 by to turn it into 35? 7. So what do I have to do to the 2? Times 7, which gives me 14. So again, 14 over 35 is the exact same value as 2 over 5. In your big book, on page 43. What we're going to do for this last hour is what we call a workshop day. I'll give you a few problems, you try them, then we'll hit the next concept. So I'm going to give you about 3 or 4 minutes to work on these on page 43. Bottom of the page there. Just do 1 through 11 the odd quick. Do those 5 or 6 problems, and we're going to go over them in about 2 or 3 minutes. So looking at page 43 there, number 1, 1/2 becomes how many 16ths? 8. Very good. For number 3, 3/4 becomes how many 30-seconds? 24. Good. Number 5, 7/8 becomes how many 30-seconds? 28. Number 7, 11/16 becomes how many 64ths? 44. Number 9, 1/4 becomes how many 20ths? 5. And finally, number 7, 19/12, and I know that's improper, but we'll talk about that in a minute, becomes how many 70 seconds? 114. Perfect. Any questions on those? Now, our next step, let's say we're looking at this, we've created this 14/35, and we want to go back. Well, we had 2/5, so we multiplied by 7 on top and bottom to make 14/35. So if we go the other way, divide by 7, 14 divided by 7 is 2. 35 divided by 7 is 5. We're back to 2/5. We've already established that those two have the same value. So what this shows is that if we have a fraction, we can divide the top and bottom by the same number, and it won't change the value either. The problem is, here we knew what to divide by because we were the one that multiplied it in the first place. The problem is figuring out what we can divide both of them by. So let's have something like, let's see here. 30/42. Now when I'm looking at fractions, I kind of go through a progression. The first thing I look for is, do they both numbers end in 0? Why would that be useful? Well, if they both ended in 0, yeah, they're both divisible by 5 or 10. If they both end in 0, they're both divisible by 10. Then I do the 5. So do they both end in either a 5 or a 0? So then they can be divided by 5 at least. If that don't work, then my next step is to look at, are they even? By even, I mean that last digit is a 0, 2, 4, 6, or 8. Both of these are even, so that answers my question to that one. So that means both of those can be divided by 2. 30 divided by 2 is 15. 41 divided by 2 is 21. But just because we've divided by something does not mean we're done. Both of these can still be divided, but now that they're smaller, it's a little bit easier to find. They can both be divided by 3. 15 divided by 3 is 5. 21 divided by 3 is 7. So often we're told you have to find the greatest common factor to divide both of them by, the biggest number that divides both of them. It's really not true. It's less work if you can. If you look at it and you see what that is, it saves you a lot of steps. Here we had to do it twice to get it reduced. But it doesn't matter. You're still going to get to the right answer. It's just more steps. And for me, once I've divided by something, like when I divided by the 2, when the numbers are a little bit smaller, now it's easier for me to look at it and see what I can divide by. So we might have something like 48/60. Looking at that, what's one thing you can see that we can divide both of those numbers by? 6. Yeah, they can both be divided by 6. 48 divided by 6 is 8. 60 divided by 6 is 10. They can still be divided by 2, 4, and 5. I heard somebody say 12 right away. Yeah, you could have divided by 12 right away. It would have saved us a step. Somebody said 2. We could have divided by 2 at the beginning. We got 24/30. We just keep going. We divide by 2 again, and then maybe 3, and we get to where we'll still get to where we want to go. It just takes more steps. Okay, so in your book, on page 44, halfway down the page, there's exercise 2-5. Once again, I want you to do 1 through 11 the odd. We'll just take a couple of minutes and we'll discuss those. Okay, so on page 44, number 1, 2/8 reduces to 1/4. Good. Number 3, 6/16 reduces to 3/8. 5, 90 over 80. 9 over 8. Number 7, 7 over 28. 1 over 4. Number 9, 48 over 64. 3 over 4. And number 11, 81 over 36. 9 over 4. Now I've got that 9 over 4 and the 9 over 8, where the numerator is bigger than the denominator. Those are what we call improper fractions. Now that implies that there's something wrong with them, and it's not. There's nothing wrong with them. In fact, there are times when we prefer them to be in that form. We call them improper, though, because it's just not the way they were designed to be used. Because this is saying it takes 4 pieces to make a whole object, and we have 9 pieces. We have more than enough pieces to make a whole object. In fact, there we could make a couple of whole objects. So when we're looking at a problem like that, what we want to do is often it's simpler to assemble our whole objects and then our pieces left over. Out of 9, if it takes 4 pieces to make a whole object, how many whole objects could we make? 2, so 2 whole objects. And how many pieces left over? 1. What are those pieces called? They're still fourths, right? This is what the name of the pieces are. So it still stays fourths. So it's 2 whole objects with 1 of those fourths left over. So exactly, it's a division and a remainder. I had said something to you about this is where remainders are useful, and this is exactly it. 4 goes into 9 twice. 2 times 4 is 8. There's 1 left over, so 1/4. So let's say I have something like 44/7. If I wanted to use the calculator to try to help me out here, I'd punch in 44 divided by 7, and I'm going to get something like 6.2857146 approximately. Does that really help me? Well, it kind of does. What it does tell me is we have 6 whole objects, right? It doesn't tell me how many pieces are left over. I could do 6 times 7 is 42, so we used up 42 pieces, and subtract to get that there's 2 left over. To me, it's still easier to do a division and remainder. Now, I'm not too bad at doing division. If you struggle with it, calculator methods will probably be easier for you. But I would do 44 divided by 7. 7 goes into 44 6 times. 6 times 7 is 42. There's 2 left over, so 2 sevens. If you were doing this on the calculator, here's what I would do. 44 divided by 7, just like I showed you here, gives you that 6.285714286. Well, what that shows is there's 6 whole objects. So I'm going to take away the 6 whole objects. That leaves me with the pieces. How do I turn those pieces back into sevenths? I multiply by my denominator again. Tell me there's 2 pieces left over. That's a little complex. Let me do another example here. Let's say that I have 25/6. Okay? That's going to be 4 and 1/6, because 25 divided by 6 is 4. That would make 24. There's 1 left over. If you needed to do that on the calculator, 25 divided by 6 gives us 4.1666666, right? How many whole objects is that? 4. So let's take the 4 whole objects off. How do I turn that back into 6? Times 6. That's 1/6. So that's 4 and 1/6. How many of you have a calculator with you? Do you have a fraction button on? You know what the fraction button is? Fraction button looks like this on most of your calculators.
Give me this.
Okay, so your calculator is set to math type mode. That ABC key allows you to enter it in the calculator. So for this, you'd type in the 25, press that ABC key, hit 6. When you hit equals, it should convert it. If you have a different type of calculator, this is for the TI. Some of your Sharps and Casios might work a little different. If if you have one of those, let me know and I'll help you figure it out. Okay. Yeah. Okay. So we can go from an improper fraction into, this is what we call a mixed number. Sometimes we want to go the other direction. What if I have this 4 1/6 and I want to turn it back into an improper fraction? Well, the first thing I need to do is I need to break these 4 whole objects back into pieces. How many pieces do each of them contain? Yeah, the denominator tells me how many pieces. 6 of them. So there's 4 times 6 is how many pieces? 24 pieces here. Do I have any other pieces? Yeah, I still have this one. So I add the 24 to that one to get 25/6. So if I have 7 2/3, I break the 7 into pieces by multiplying by the 3. What's 7 times 3? 21. I add that to my other pieces. 2 plus the 21 is 23/3. Or if I have 3 4/5, what do I do? 3 times 5 is 15, so I add the 15 to the 4. 19/5. What do you think? Better than a sharp stick in the eye? So to finish you guys off for the day, we're going to be looking at page 45 through 46. Exercise 2-7, problems 1 through 29, the odds. Next Tuesday, we'll look at operations with fractions. Wednesday, probably a quiz. I'm not going to keep warning you when quizzes are coming up. But then we will finish up Unit 1 here relatively quickly. Yeah, quiz on Wednesday. Probably another quiz on Thursday, too. So, quiz on Wednesday. What's that? And Saturday? Sure. I'll leave it out for you. I would discuss decimals. I'm just trying to figure out when our test is coming up here. Our test is probably coming up about 2 weeks from today, just so you know. Somewhere in that range. So our Unit 1 test is coming up pretty quickly.